Hi guys, I'm going to actually teach you now how to build the first 18 elements on the periodic table. Now last week you learned the parts of the atom and you learned how to find the number of protons, electrons, and neutrons in an atom from the periodic table. We're going to be looking at the first 18 elements on the periodic table and we're going to be building those particular atoms. Now, it would be real easy to find the protons, electrons, and neutrons, and we know that in any atom, the nucleus contains the protons and the neutrons. And when you're building these atoms, you can place the protons and the neutrons together in the nucleus. But what you'll notice is that the electrons are placed in the electron cloud in a certain pattern. Those electrons are going to be on what we call energy levels, and they're going to be at fixed distances. So let's take a look. We have the first atom on the periodic table, which is hydrogen. We know that hydrogen has the atomic number 1, so that means it has a proton number of 1, electron number of 1, a mass number of 1, and that is rounded. The number of neutrons is 0, because we take 1 minus 1, we subtract the mass minus the atomic number, and we're left with the number of neutrons. Now you're ready to build your atom. So we know that in all atoms, the proton and the neutron go in the nucleus. You do not have to draw a nucleus in to build your atom. All you have to do is write the number of protons, so we'd have 1 proton, and since we have no neutrons, we're not going to draw the neutrons in. And then we're left with 1 electron. So where do I place that 1 electron in the electron cloud? If you'll notice, there are 3 different energy levels in the electron cloud. The first energy level can hold up to 2 electrons. The second energy level can hold up to 8 electrons. Notice the empty spaces. The third energy level can hold up to 8 electrons. When you get into high school, you'll learn that it can actually hold up to 18, but for our purposes, we're going to learn that the third level can hold up to 8. Now here's the deal. You have to fill in the first level first of electrons before you can move on to the next energy level, and so forth. So basically, when you're building an atom, you want to build from the center and then move outward. Let's take a look at helium. Helium is the second element on the periodic table. Its atomic number is 2. So that means it has a proton number of 2, an electron number of 2, and its atomic mass is 4. To find the number of neutrons for helium, we would take 4 minus 2, and then we're left with 2 neutrons. Now I'm ready to build my atom. So what goes in the nucleus? I have 2 protons, 2 neutrons, and then I have 2 electrons. Now my first energy level can hold up to 2 electrons, so I'm going to draw in, color in 2 electrons. If you'll notice, I don't need the second or the third energy level. So when it says the number of energy levels, I'm going to put 1 because I only needed 1 energy level to build that atom. The next question says, is the last energy level full? That's referring to the last energy level that you used. You would have to look, is my last energy level that I used, is it full? And you would say yes, because the first energy level can only hold 2. So it is full. Let's take a look at lithium, atomic number 3. Lithium has 3 for its atomic number, so that means it has 3 protons, 3 electrons. Its atomic mass is 7, and so its neutron number is 4. You are now ready to build the atom. You would place 3 protons in the nucleus, 4 neutrons in the nucleus, and since you have 3 electrons, you would place those electrons on the energy levels. You have to ask yourself, can I place all 3 electrons on the first energy level? The answer is no. The first energy level can only hold 2 electrons. So I would say 1, 2, and then I would have to put my third electron on that second energy level. I don't need the third energy level, so I'm going to cross it out, and then over here I'm going to write that I need 2 energy levels. Is the last energy level that I used, is it full? The answer is no, because you can see that there are 7 empty spaces for electrons. Let's move on to beryllium. Beryllium, its atomic number is 4, which means its proton number is 4, its electron number is 4, its atomic mass is 9. So to find the number of neutrons, you would say 9 minus 4 is 5 neutrons. Now you're ready to build a beryllium atom. You would place 4 protons in the nucleus, 5 neutrons in the nucleus, and then you would place your 4 electrons on the energy levels that they belong to. So I need 4 electrons, so I would place the first 2 on the first energy level, and then I need 2 more, so now I move on to the second energy level. So I say 1, 2, 3, and 4. I do not need the third energy level, so I would write the number of energy levels is 2, and is the last energy level full? No, you can still see there are empty spots or spaces on that second energy level. Remember, you may not move on to the next energy level until the one before it is full. So you can't place electrons on that third energy level until that second energy level is full. Let's move on to our next atom on the periodic table. Our next atom is boron. Boron has the atomic number 5. So boron has 5 protons, 5 electrons. The atomic mass is 11 once it's rounded. So that means that boron has 6 neutrons. Now you're ready to build your atom. You would place 5 protons in the nucleus, 6 neutrons in the nucleus, and then you would need to place your 5 electrons on the energy levels that they belong to, following the pattern. So I would put my first 2 electrons on the first energy level. So I would go 1, 2, 3, 4, and 5. I do not need the third energy level, so I would say that I just need 2 energy levels for this atom if I were building it. Is the last energy level full? No, because it still has 1, 2, 3, 4, 5 empty spaces. You may ask yourself, why did Miss Whitehead go all the way around to draw in her electrons? Why did I not just bubble these in together? You could do that. You could actually bubble them in together, because really the electrons could be placed anywhere on the energy level, because technically the electrons are moving, aren't they? They're moving around and they're traveling along that energy level. So they're actually moving. So really you could place your electrons anywhere, but we're going to space them out so that in the future when we learn about bonding, or when you learn about bonding in high school, it will make more sense. So just space your electrons out like I am doing. Okay, if you forget, it's okay. You would just need to make sure that you have the right number of electrons on that particular energy level. Okay, let's go ahead and do carbon. I want to do a couple more with you, and then I'm going to let you try it. Okay, so the atomic number for carbon is 6. The proton number is 6. The electron number is 6. The mass number is 12. So my number of neutrons then is 6. Now you're ready to build a carbon atom. you're going to place 6 protons in the nucleus, 6 neutrons in the nucleus, and then now you have to place your electrons in the correct placement. So I would go 1, 2, 3, 4, 5, work my way around, and 6, spacing those electrons out. I do not need the third energy level. So if you were to actually draw this atom, you would only draw it with 2 energy levels, 2 orbitals. That's it. Okay? The number of energy levels is 2. And is the last energy level that I used full yet? No. You can see, though, we're increasing the electron number each time. So eventually that second energy level is going to be full, and we're going to move on to that third energy level. Nitrogen, the atomic number is 7, proton 7, electron 7, mass number is 14. Neutrons then are 7. Now you're ready to build your nitrogen atom. So we would have 7 protons, 7 neutrons, and then a 7 electrons. So remember your rule. First energy level can hold 2 electrons. And you can refer to your note sheet that's attached to the Google Classroom. There will be a set of rules for building atoms if you forget. So 1, 2, 3, 4, 5, 6, and you're going to come back around, and 7. I do not need a third energy level, so I would just do 2. And then is the last energy level that I used full? No. What you're going to notice about all of these elements, boron, carbon, nitrogen, all of these elements on this page are found in row 2, period 2 of the periodic table. Notice that each one of these atoms also has 2 energy levels. So what that means is that any element on row 2, period 2, will have 2 energy levels when you draw its atom. Any element in period 1, row 1, which is hydrogen and helium, they will only have 1 energy level. And so you can kind of see the pattern unfolding. When you get to the third period or third row on the periodic table, all of those elements are going to end up having 3 energy levels. So as you work through these and draw these atoms and continue drawing these atoms, you're going to continue drawing all the way to atomic number 18, argon. So when you finish your journal pages, the very last one, argon, all of your electron spaces should be full. Again, if you forget and you need a refresher on how to draw atoms, you can watch this video again, or you can refer to the rules for building atoms attached in Google Classroom. All right, guys, go and finish your student journal and submit. Bye-bye.